A consumer lives for 2 periods, current, period 1, and future, period 2. Her utility function is U of C underscore 1, C underscore 2 equals L, N of C underscore 1, plus beta L N of C underscore 2, where C underscore 1 and C underscore 2 are consumption in period 1 and 2, respectively, and beta equals 0.9 is the discount factor. Her income in period 1 is Y underscore 1 equals $100, and in period 2 is Y underscore 2 equals $121. The interest rate for saving or borrowing is R equals 0.10 or 10%. A. Write down the intertemporal budget constraint. Explanation. The intertemporal budget constraint shows the total amount of consumption a consumer can afford over all periods, given their income in each period and the prevailing interest rate. It can be expressed in 2 ways. 1. Future value, FV form. Total present value of income equals total present value of consumption. C underscore 1 plus frac. C underscore 2 1 plus R equals Y underscore 1 plus frac. Y underscore 2 1 plus R. 2. Present value PV form. Total future value of income equals total future value of consumption. C underscore 1 1 plus R plus C underscore 2 equals Y underscore 1 1 plus R plus Y underscore 2. Both forms are equivalent. Let's use the PV form, as it's often more intuitive, for immediate calculation of income and consumption, and then also derive the FV form. Solution. Given is to Y underscore 1 equals $100, Y underscore 2 equals $121, R equals 0.10. Using the present value, PV form is to C underscore 1 plus frac C underscore 2 1 plus R equals Y underscore 1 plus frac Y underscore 2 1 plus RC underscore 1 plus frac C underscore 2 1 plus 0.10 equals 100 plus frac 121 1 plus 0.10. C underscore 1 plus frac C underscore 2 1.10 equals 100 plus frac 121 1.10. C underscore 1 plus frac C underscore 2 1.10 equals 100 plus 110. C underscore 1 plus frac C underscore 2 1.10 equals 210. We can also express this in the future value of FV form by multiplying the entire PV equation by 1 plus R. C underscore 1 1 plus R plus C underscore 2 equals Y underscore 1 1 plus R plus Y underscore 2. C underscore 1 1.10 plus C underscore 2 equals 101.10 plus 121. C underscore 1 1.10 plus C underscore 2 equals 110 plus 121. C underscore 1 1.10 plus C underscore 2 equals 231. Intertemporal budget constraint, PV form. C underscore 1 plus frac C underscore 2 1.10 equals 210. Intertemporal budget constraint, a Veritone Mangeshi V form. 1.10 C underscore 1 plus C underscore 2 equals 231. B. Set up the Lagrangian for utility maximization. Explanation. To find the optimal consumption levels, we use the method of Lagrangian multipliers. We want to maximize the utility function subject to the intertemporal budget constraint. The general form of the Lagrangian is mathcal L, C underscore 1, C underscore 2, lambda, equals U of C underscore 1, C underscore 2, minus lambda constraint. Solution. Utility function, U of C underscore 1, C underscore 2, equals L N of C underscore 1, plus 0.9 L N of C underscore 2. Budget constraint, using the PV form for simplicity, C underscore 1 plus frac C underscore 2, 1.10 minus 210 equals 0. The Lagrangian function is mathcal L, C underscore 1, C underscore 2, lambda equals L, N of C underscore 1, plus 0.9 L n of C underscore 2 minus lambda left C underscore 1 plus frac C underscore 2. 1.10 minus 210. Right. Lagrangian function, mathcal L, C underscore 1, C underscore 2, lambda, equals L n of C underscore 1, plus 0.9, L n of C underscore 2, minus lambda left C underscore 1, plus frac C underscore 2, 1.10 minus 210. Right. C. Find the optimal consumption levels. C underscore 1 to the power of n C underscore 2 to the power of. Explanation. To find the optimal consumption levels, we take the partial derivatives of the Lagrangian with respect to C underscore 1, C underscore 2 and lambda and set them equal to 0. This gives us the first order conditions, FOCs. From these, we derive the relationship between C underscore 1 and C underscore 2, often called the Euler equation or MRS condition, and then substitute it back into the budget constraint. Solution. First order conditions, FOCs. 1. Frac partial mathcal L partial C underscore 1 equals frac 1. C underscore 1 minus lambda equals 0 implies lambda equals frac 1. C underscore 1. Equation 1. 2. Frac partial mathcal L partial C underscore 2 equals frac 0.9 C underscore 2 minus frac lambda 1.10 equals 0 implies lambda equals frac 0.9 times 1.10 C underscore 2 equals frac 0.99 C underscore 2. Equation 2. 3. Frac partial mathcal L partial lambda equals minus left C underscore 1 plus frac C underscore 2 1.10 minus 210. Right equals 0 implies C underscore 1 plus frac C underscore 2 1.10 equals 210. Budget constraint. From equation 1 and equation 2, we can set the expressions for lambda equal. Frac 1, C underscore 1 equals frac 0.9 C underscore 2. Cross multiply to get the relationship between C underscore 1 and C underscore 2. C underscore 2 equals 0.9 C underscore 1. This is the Euler equation. MRS equals 1 plus R. Now substitute C underscore 2 equals 0.99 C underscore 1 into the budget constraint. C underscore 1 plus frac C underscore 2 1.10 equals 210. Is to C underscore 1 plus frac 0.99 C underscore 1 1.10 equals 210. C underscore 1 plus 0.9 C underscore 1 equals 210. 1.9 C underscore 1 equals 210. C underscore 1 to the power of equals frac 210 1.9. C underscore 1 to the power of equals frac 2119 approx 110.53. Now, use C underscore 1 to the power of to find C underscore 2 to the power of is to C underscore 2 to the power of equals 0.9. 9. C underscore 1 to the power of C underscore 2 to the power of equals 0.9. 9 times frac 2119. C underscore 2 to the power of equals frac 2079. 19 approx 109.42. Optimal consumption in period 1, C underscore 1 to the power of equals frac 2119 or approximately $110.53. Optimal consumption in period 2, C underscore 2 to the power of equals frac 2079.19 or approximately $109.42. D. Will the consumer be a saver or a borrower in period 1? How much will she save or borrow? Explanation. To determine if the consumer is a saver or a borrower in period 1, we compare her optimal consumption in period 1 C underscore 1 to the power of accounts with her income in period 1 Y underscore 1. If C underscore 1 to the power of less than Y underscore 1, she saves in period 1. If C underscore 1 to the power of greater than Y underscore 1, she borrows in period 1. If C underscore 1 to the power of equals Y underscore 1, She neither saves nor borrows. The amount saved or borrowed is simply y_1 minus c_1 to the power of pow. If the result is positive, it's saving. If negative, it's borrowing. Solution. Consumer's income in period 1 y_1 equals $100. Optimal consumption in period 1 c_1 to the power of equals frac 2119 approx $110.53. Compare c_1 to the power of and y_1. Since c_1 to the power of asterisk $110.53 greater than y_1 $100, the consumer will be a borrower in period 1. Amount borrowed in period 1 equals c_1 to the power of asterisk minus y_1. Amount borrowed equals frac 2119 minus 100. Amount borrowed equals frac 2100 minus 1919. Amount borrowed equals frac 219, approx 10.53. The consumer will be a borrower in period 1. Amount borrowed equals frac 219 or approximately $10.53. Verification. If she borrows $10.53 in period 1, she has to repay this amount plus interest in period 2. Amount to repay in period 2 equals loan times 1 plus r equals frac 219 times 1.10 equals frac 22019. Her total resources in period 2 would be y_2 minus text repayment 121 minus frac 22019 equals frac 12019 equals frac 222019 equals frac 2299 minus 22019 equals frac 207919. This exactly equals her optimal consumption, c_2 to the power of equals frac 207919, confirming the solution.